Hello everyone. Good morning. Good afternoon. Thank you for joining. My name is Sue Yarger, and it's my pleasure to be your host for today's session covering mapped security in the Under the Hood series of HP Idle. Before we begin, I'd like to review some housekeeping items. Today's session is being recorded. It will be available about an hour after the session concludes using the same registration link found in the invitation. If your screen resolution is too small and you'd like the slides to appear larger, you can maximize the presentation space by clicking the small box located in the upper right-hand corner of the presentation window. If you'd like to ask a question, you may do so at any time during the session. Enter your questions in the Q&A window and then click Ask. Thank you for joining us for this next segment of Under the Hood as we take a deeper look at map security in HP Idle. We will see how map security is used to enhance the enterprise search index and preserve user access entitlements across all data sources. Today, we'll hear from Ben Green, Director of Pre-Sales in Information Analytics. We will answer as many questions as we can at the conclusion of today's session. I'll pass the microphone over to Ben to get things started. Please, go ahead.
Thanks, Sue. Good morning, everyone. Good afternoon, good evening, depending on where you're watching this from. Today, we'll be following up with another installment of HP Autonomy's Under the Hood of HP Idle webcast series. The series is all about going behind the scenes of HP's Intelligent Data Operating Layer, or IDLE, an advanced technology that harnesses all types of information to enrich solutions and power applications that deliver incredible insight via the various types of analytics that it can produce. I'm your host this time around. My name is Ben Green. I'm Director of Pre-Sales for HP. I look after the information analytics and OEM pre-sales organizations across the U.S., Canada, and Latin America for HP software. Today, we're going to place a spotlight on map security in HP Idle. I'm going to walk everyone through what map security is and why it's needed, the architecture, and how map security enhances an enterprise index. Let's get started. There's a lot of really in-depth and technical definitions for map security, but the easiest way to think about it is as a means of translating or implementing the same security measures that protect data inside of their source. And by source, I mean the enterprise repository where that data is being stored, whether that's a file system, an ECM system, an archive, an email server, and basically maintaining those same security measures inside of IDLE. That essentially means all the information and the metadata is protected in the same way inside of IDLE that it is natively inside of the source. So let's go a little deeper on this. All the data comes with a cost of ownership, and a huge part of these costs are justified based off of the value of the data that's being stored in these systems. Enterprises protect this information, and for good reason in different ways, depending on where the data originates from. SharePoint, for instance, uses direct integration with services like Active Directory and its own proprietary security model to decide which people or groups of people can actively view or edit documents across the entire enterprise, depending on where they are, what groups they're in, etc. EMC Documentum, IBM Filenet, and Hadoop all also use their own proprietary set of security frameworks to protect their data. Now, the real question is if you intend to create a unified access solution that points to all these enterprise data repositories, can you access all that information and still maintain and preserve the integrity of that information at the same time by mapping those same security frameworks directly to the unified information access solution? And that's why we have IDLE. Now, when we look at IDLE as a platform, we're calling it a unified information access solution, which basically means that it provides various analytic services to different applications that are leveraging it to provide those incredible insights I was talking about earlier, whether they're knowledge management functions, search functions, clustering functions. All those different functions are being leveraged across all the data that's being ingested across the different repositories that are out there. Now, due to the wide array of file types and repositories that IDLE can ingest, it's not always enough to simply understand the context of the information inside these files or simply analyze it. The security that protects the information inside of these different places is a huge part of its context, and it needs to be accounted for in some way during the analytics process. Now, what I plan on showing in this session is that the information needs to be indexed, and by information I mean security information needs to be indexed alongside the data when it's being pushed to a unified information access solution, so that we can determine who can see that data and act on it in different ways in real time. Now, without understanding that security dimension in real time as part of the analytics process, what you do is you risk data loss, and you also put the organization at risk and drive further inefficiencies down the line for your end users. Let's talk a little bit about these risks now. Everyone knows that data is very powerful. That's why the world is in the midst of this data revolution that people are calling big data. What big data also opens us up to is risk, because only a certain subset of all information people can really see and act on in a given way, depending on what security is implemented. If you think about it in simple terms, in every enterprise you have things like email data, you have SharePoint data, you have other ECM data, archive data. That's all accessible by certain people in certain ways. Nobody can see everything, and it's for a reason. What complicates matters is that it's typically generated in heavy volumes and speeds that are difficult to manage. That's why we call it big data. We call it managing the 4 V's. Volume, velocity, variety, and veracity are all important parts of the big data puzzle. And IDLE happens to manage these characteristics of data better than most. But whether you can deal with that volume and speed and do so securely is also a really important question, and that's what we're going to answer today. Those vendors who can't do this sort of thing are putting their company at risk. Organizations, enterprises, you name it, try to avoid this problem in many different ways, and it's an incredibly hard problem to solve for a variety of reasons. And chief among those reasons is really the complexity of security models that are out there. Now let's take a look at why serving all this information back through a unified access solution really is difficult. If we take a look at 3 very common ECM vendors and how they typically secure data, the general rule in most organizations is that every vendor implements security differently. Even the same vendor solutions often have variations, customizations to their own security models implemented on behalf of their customers, and there really needs to be a way to account for them. Now, all of these particular platforms have IDLE connectors, so on the surface, it's pretty easy to index this information if you own IDLE on these connectors. But if we dig a little deeper and start to really read into the security surrounding the data stored in these systems, things start to look pretty different, and they get a lot more complex. Each one of these systems has different authentication standards and totally different authorization frameworks. And when I say authorization frameworks, I'm going to talk about this a little later, but what I mean is how the system controls access to their documents. Now, I don't want to go into too much detail about these specific systems now because it's not important for the session. The basic takeaway is that things get very messy real quickly. Unified information access solutions have to figure out how to manage this complexity inside of IDLE or the vendor of their choice. That is, if you want people to be able to analyze this data in a cost-effective, secure, and efficient way. Now, I'm not going to lie to everyone and say there aren't workarounds for this problem, but it's important to realize that the workarounds aren't necessarily the way to go. And the reason is that the various workarounds, like instituting rigid workflows to control who can see what based off of who they are, other solutions can't be perfected to accurately reflect the permissions implemented across these systems. I mean, most companies are dealing with millions upon millions of documents, each with a different set of permissions. Further, they have thousands of users. So writing workarounds for those documents isn't scalable or feasible. You're going to literally be paying people to do it for you. So most vendors, to avoid that particular workaround, use a different workaround that we like to call late binding or unmapped security. And as an example of what not to do and what not to architect for your systems, we can take a look at a generic late binding solution. Let's take, for an example, an enterprise, we'll say it's owned by Steven Spielberg, that has indexed a bunch of popular film metadata from various repositories like Hadoop, SharePoint, Dropbox, and Filenet. Let's also assume that this data has been secured uniquely using the distinct security models each of these systems is well known for. Maybe they're all storing some shard of IMDb for demonstration purposes. Again, this may not be a realistic example, but let's go with it for now just to prove out a point. Typically, the way this process will work is that you'll have an end user, Steven, in this case, Steven Spielberg, who will want to institute a search against some measure of a federated index, which is not idle in this case. He'll send a request to that federated index, which will be pointing at a set of source repositories. In this case, SharePoint, Hadoop, Dropbox, and Filenet. Alongside that federated index is an unmapped security layer that will be responsible for communicating with these source repositories as part of the querying process. Now, here's where things get a little interesting, or a little terrifying if you look at it from the standpoint of an enterprise. This application will start to receive results from the federated index one at a time. In the first example, we get one result back, History of the World Part 1, and as we get that, as each set of results comes back, the federated index needs to check using the unmapped security layer with each of those source repositories that the end user, Stephen, can see those documents. This goes for Beverly Hills Cop, Braveheart, and Footloose. Now, most employees are only allowed to see about 1 in 10,000 documents inside of an organization. That means in order to create a results list of 10, the system actually has to do about 10 times 10,000 operations. That's a lot of queries for a single query being run against the system. You're going to wait ages just to get results back. Also, each request is going to be translated into multiple requests depending on which repositories are in use. In this case, Stephen has access to 4 different repositories. Further, you're going to have to reconfigure settings when people are leaving or promoted or fired because things change, the organizational hierarchies are changing, and all that has to be reflected as part of the unmapped security process. Now, the problem is that these repositories that are being deferred for all these requests are not designed for that kind of traffic that comes with a unified information access solution. They may go from doing 1 request per user per day to 10,000 requests per user per day. And what's going to happen is they get white hot and they're going to just melt. They're going to stop working. UIA solutions need to index all the security information alongside data to be effective, and that's what we're going to discover in subsequent slides. This means that we're not going to have to go back to these source repositories to confirm that end user Stephen can access all these relevant results. We're going to have a completely disparate framework for managing all these processes for us without having to go and run off to different systems to confirm or deny access to given resources. What Autonomy uses to manage all this complexity associated with the different security protocols that are in place across all these systems is called the Intellectual Asset Protection System, and we also call it the Framework for Map Security. And what it does is it uses 3 core pieces of information to grant a user access to information in as seamless a way as possible. The first piece of information, of course, that it requires and manages for us is the authentication process, which is basically confirmation that a person is whom they say they are. The second, the user identities, is just a measure of what a person is in the context of the enterprise. Just knowing who a person is isn't necessarily enough to collect the information you need to determine who can see what inside of a repository. You need to know which repositories they have access to. Every system is going to be different. Stephen is going to have a different username for each repository. He's going to be a member of different groups in each repository. And this particular problem can get enormously complex when you consider all the different users inside of an organization and all the various groups and objects that are out there that have different permissions applied to them. Finally, the document authorization and security information, which has to do with all the different documents that are being managed by the Unified Information Access Solution. Oftentimes, in different situations, we're dealing with every single document in an enterprise having its own security context, which means its own set of permissions that determine who and what can see this data. We call these access control lists, and they are the linchpin, really, to every security model or map security model that's out there. Every document's going to have one, and they can theoretically all be different from each other. So it's going to make our lives a little difficult, but what we're going to discover is that IDLE has a very interesting and manageable way of dealing with this problem. So let's dig in a little bit on authentication. The way IDLE handles this particular process is through a set of services that we call the community services, which effectively offer a host of deferred authentication services that can communicate with popular authentication protocols like SiteMinder, like Windows and LDAP, and many more. These authentication services can be leveraged directly via the HP Autonomy ACI API, so that this functionality can be served seamlessly just like any other function, whether it's a query, a clustering action against idle. Thus, we can authenticate users and do so in a way that's familiar to all the developers who are building their own applications or working directly with idle, and they can do it the same way that they're used to. The steps, particularly for authentication, are pretty simple. The application sends a request from the end user that includes his credentials. Of course, all this is encrypted. idle will then receive the request as the second part of the process and execute a handshake with the deferred login method of the application's choice. And keep in mind that the app can also handshake with several systems if that's required. We're going to do one in this case. And then finally, idle will receive confirmation from the authentication service that the person is who they say they are, and it will move on to the identity process. To really provide a thorough understanding of who somebody is in the context of the enterprise, it's not just enough, as I said, to get an authentication result and say, yes, this person is Stephen from said company. To fully understand the enterprise identity, or the person's identity across all these different repositories that we're going to have indexed inside of idle, you need to manage all that information as part of the index. Someone's username or credentials may be different depending on the repository. Further, security privileges are not guaranteed to be the same across each one of these systems. So the data across every single one of these repositories needs to be treated differently, and idle is there to manage that complexity by understanding the users, the relationships to their data, and consequently, who can see what data under which circumstances. With unified information access, it's important to understand that every data point that we're going to be indexing has to be treated uniquely, and broad characterizations across data sources only serve to violate a security model in most cases, and that's going to put your organization and your data at risk. In this particular case, idle's identity or group services is simply going to be polling each one of these systems in the background for information around all their users, what the username is, what usernames map to which users, what groups map to which usernames. And we're going to store all that information as part of the index so we can use it as part of our querying process against a wide array of documents that are going to be stored on behalf of idle. Now also keep in mind, specifically this process is something that's likely going to be taking place in the background of every system. It's assumed that as systems are implemented, the identity management process is going to be executed as part of the implementation beforehand and preloaded so that we're not dealing with any sort of identity management concurrency issues with the queries themselves. So for the purposes of enterprise architecture, you can just assume that this is just going to be living and breathing alongside idle. Now this finally brings us to arguably the most important aspect of how idle manages the underlying security measures across documents, and that's through what we call the idle content services. Document security and authorization is really a combined set of features that are powered both by the content services along with the connectors. Basically, what happens is we have a set of connectors that are going to be communicating with the different repositories that are out there. In this example, I think I have Filenet, EMC Documentum, and SharePoint. And the connectors are going to reach out into those repositories using the native APIs to capture all the data from the repositories. Now this is typically what the data looks like. It's a collection of different metadata and important information surrounding the file. Idle also reaches into the file itself and pulls out all the important core text that it's going to be using to drive the various analytics functions that are part of the framework. And most importantly, it's going to capture a specific set of information that we call the access control list associated with the different documents. That access control list is going to determine specifically which users can see this file based off of the underlying privileges in the source repository, what users can't see the file, what groups can see the file, and what specific groups are not authorized to see the file. And depending on the repository, there will be a whole host of other metadata that's going to determine who can see what as part of that access control list. Now, in this particular example, you're seeing a blob of text that doesn't make any sense because I don't want to show a security ACL of a given document anywhere. I mean, you're in all likelihood only going to be dealing with encrypted data when you're managing a system anyway. So you can use your imagination to what's going to live inside of these different text strings. And finally, as part of the process, the connectors are going to create an indexable object, or what we call an IDX object, that are then going to be securely pushed to the content service. This means that we're going to be digitally binding both the metadata and the access control list of documents directly to the idle index, which which means all the important core security information is going to be stored in the index versus outside of it, which is what we saw before in the wrong way example. Now let's look holistically at all these capabilities as a collective set of platform features that can be implemented against the same system we discussed earlier. This time we'll be using IDLE, which is previously indexed all this information coming from our source systems, SharePoint, Hadoop, Dropbox, Filenet, along with the security details of the data and the user information that's been stored inside of each one of those repositories. Now, Steven Spielberg will be the same character that's running a search against an app as part of his enterprise that is now powered by HP's Intellectual Asset Protection System. Now, to start, we'll authenticate Steven against IDLE using the community services that are embedded as part of the underlying platform system. This community service will defer the login to a third-party authentication framework like LDAP or SiteMinder, whatever, and confirm or validate his identity. Once we understand that this is indeed Steven, IDLE will then use its identity management services to gain an understanding of who Steven is in the context of the many different repositories accessible by his identity. We call this identity or the enterprise identity. Now finally, using all this information and security context that we have as a result of these different processes taking place behind the scenes, we're going to query IDLE content services for results. As IDLE identifies potential hits, it uses Steven's identity information to cull the responsive results to only the information that Steven is allowed to see per the source repository-specific security model. Regardless of the fact that all this information comes from different places with different security systems, IDLE is able to uniquely identify the set of results that Steven is permitted to see based off of his entitlements. It doesn't need to request authorization rights for every single document that is returned like before. Every part of this process is managed by IDLE inside of IDLE, which means we're not going anywhere else. We can do everything within the same framework. And that's really all that's involved, folks. Mapping security information to the UIA solution is really the only efficient way of managing the breadth and complexity of security scenarios that are out there. If you can't do it, you risk, one, the organization as a whole due to data leakage problems and access violations. You don't want people in the enterprise seeing information they shouldn't be seeing. It's a tenet of any information management solution. And then two, you risk the IT infrastructure being paralyzed as a result of these unmapped security processes. Unmapped security is a wholly inefficient solution that, when implemented, can bring your IT infrastructure to its knees. So you need to avoid it at all costs. And that about wraps things up for today, folks. Thanks again for tuning in to this version of Under the Hood of HP IDLE. At this time, I'd like to take some Q&A from the group.
Great. Thank you very much, Ben. Audience, if you've not done so already, please submit your questions in the Q&A box and then click the Ask icon. We'll give you a few moments to get your questions in. And Ben, a couple of questions have been submitted so far. The first one, does implementing map security add a lot of complexity to the installation?
The short answer is no. As a result of having all of these different processes in place and as part of the underlying framework, it's going to add some time to the implementation process, but typically it's all managed natively by the system, and it's not going to add a lot of overhead or planning to your indexing process as long as you plan ahead of time. Great question.
All right, thank you. Here's another one. How many security frameworks are covered by HP's map security system?
I believe out of the box, HP's map security framework or intellectual asset protection system has about 15 authentication and authorization frameworks out of the box. Our development team is always looking to build more, depending on the use cases that are out there, and we're always open to different enhancement requests that come from our customers. For those of you that don't see what needs to be covered through the IDLE documentation, please work with me or with your sales rep to determine whether the viability of having Autonomy or even yourself produce an authentication or an authorization framework.
Okay, thank you. I think we have time for just one or two more. Here's one. Can map security be customized for specific vendors if they use non-standard security models?
That's a great question, and the answer is yes, it can. A huge advantage to IDLE's intellectual asset protection system is that it has a customization component, which means that users can actually write their own authorization frameworks that can be used alongside IDLE with proprietary setups, proprietary security systems, and really whatever variations of different security models that are already out there. Great question.
Okay, and I think we have time for just one more here. What if your map security libraries don't cover a specific authorization or authentication framework we'd like to use?
In this case, I'd highly recommend you work with me, work with one of your account reps to figure out the viability of getting that put on the docket for our roadmap, or work directly with me and the engineering team to make sure that we can make that part of our ongoing planning as part of the intellectual asset protection system.
All right. Thank you. Thank you very much. I think we've run out of time here. I apologize if we were not able to get to your question. I'll forward all unanswered questions over to Ben to follow up. I'd like to thank Ben again for a great presentation. Before you leave today, we'd like you to complete a survey by following the link that you can find on this page. Your comments are always appreciated in helping us improve future sessions. The survey is totally anonymous and should only take a few moments to complete. If you missed any of today's session, it will be available in about an hour using the same registration link found in the invitation. That concludes our session today. Thank you very much for your time, and have a great day, everyone. Bye.